Hello, my name is Corey Whittam, and I'm a master's student in the Wildlife Ecology program, co-advised by Dr. Steve Coughlin and Dr. Joe Zaleski. Today, I will be presenting on how the fish assemblages of the Penobscot River have responded to dam removals and increased connectivity within the watershed. I figured we'd start with some background information of the Penobscot River watershed to understand how we got to where we are today. The Penobscot River has been home to indigenous peoples for an estimated 11,000 years. Following European colonization, the state of Maine has been, and still to this day, home to extensive timber harvesting practices. Historically, rivers played a key component in the transport and processing of the harvested timber. Large-scale dams were constructed in order to control both flow for timber transport as well as for harnessing mechanical power for processing the timber. Lumber mills developed along the rivers, which in turn financially supported the surrounding areas. Over time, timber transport shifted from rivers to logging roads, marking 1971 as the last year for the Penobscot to host the log drive. Many lumber mills converted into pulp and paper mills as demand shifted, and at times these mills often discharged chemical wastewater such as mercury into the river along with effluent warm water from cooling their machinery. However, today the primary influencer of the Penobscot River and many others is the hydropower industry and all those that rely on this power production. So the Penobscot River watershed is actually the largest watershed in the state of Maine, draining roughly 1/4 of the entire state. In total, there are 425 river kilometers within the watershed, and prior to 1830, there were no anthropogenic dams constructed. Fast forward roughly 180 years later, and there are 113 dams present, 20 of which are used for hydroelectric power generation. However, arguably the most important part of this watershed is that it's home to 12 species of sea-run fish that have all co-evolved together. And in addition, the Penobscot River is home to the largest remaining run of Atlantic salmon in the United States. So these sea-run fish play a critical component in the state of Maine's economy and culture. American eel offspring added over $20 million to the Maine economy in 2019. In addition, species such as alewife and blueback herring contributed to the bait fish supply for Maine lobstermen, which can lower the overall cost for bait for lobstermen. The striped bass fishery was estimated to add over $6 million to the state's economy in 2020. And interestingly, the Penobscot River previously provided the presidential salmon every year to the president, marking 1992 as the last year this annual tradition to occur. Pictured here is a rainbow smelt along with smelt shacks out on the lower Kennebec River, where Maine anglers can catch up to 4 quarts of these fish per day. And finally, indigenous peoples have depended on these fish for thousands of years to provide sustenance. Pictured here is a member of the Penobscot Indian Nation fishing along the banks of this river. So dams have profound lasting effects on both the biotic and abiotic factors within the system they're constructed in. Using this graphic, I'll demonstrate some of the major effects these structures have. So we'll place a dam in, and the first thing we'll notice is we lose the ability for the river to have dynamic flow regimes as these flows become much more controlled. These dynamic flow regimes create a natural disturbance within the river that helps maintain biodiversity. And in addition, we see an increase in the volume of water above the dam with significant reduced water velocity. With this decreased water velocity, we'll see an increase in the water temperature as the water has more time to heat up now. In addition, these impoundments create refugia habitat for many of these species that might not normally be present there as compared to the free-flowing section of river. Many of these species within the refugia habitat are often non-native species as well. We also lose the flow of sediments and nutrients as much of these sediments begin to fall out of the slower water and accumulate just above the dam. But arguably the most significant impact these dams have is the barriers they present to migratory fish as they're trying to reach their critical spawning habitat. And so here we have an adult American eel on the left trying to migrate out of the system so that it can spawn in the Sargasso Sea. And on the lower portion of the dam is our anadromous species that are trying to run upriver so that they can spawn within the river. With the goal of rehabilitating the Penobscot River and the populations of sea-run fish that inhabit it, the Penobscot River Restoration Trust was formed. This project resulted in the removal of the 2 lowermost dams along the river with upgraded fish passage at remaining dams. This opened up over 3,000 kilometers of riverine habitat for migratory fish to inhabit and potentially spawn in. So large-scale habitat restoration efforts from the Penobscot River Restoration Project impacted both resident and migratory fishes within the Penobscot River as connectivity increases were made within the watershed. So for my project, I'm now focusing on the long-term extended influence of dam removal and upgraded fish passage on fish assemblages 7 to 9 years following restoration efforts. So main stem river sampling is carried out in the beginning of lower river, going all the way up to Howland during spring surveys to follow the runs of adult sea run fishes. Sampling is then repeated in the fall, coincide with the outward migration of these juvenile fishes as they're working their way back out into the ocean. We use a stratified random sampling design within our study area, split into 4 major strata. Within strata are separate reaches that contain delineated 500-meter long transects, in which we sample 3 to 6 transects per reach. In addition to our stratified random sampling design, we use a fixed site sampling method, which consists of 19 total fixed sites, each of which are 1 kilometer long. Fixed sites within the main stem river are primarily located immediately upstream and downstream of current or former dams, as these are areas we'd expect to see some of the most significant changes occurring. And then this fixed site design also allows us to sample 6 tributaries that flow directly into the Penobscot River. So tributaries are identified as lower tributaries if they are upstream just one dam. So that's that one dam would be Milford Dam. And tributaries are identified in our study area as upper if they are upstream more than one dam. So I've included some photos here to highlight our sampling method. Here's a picture of us on the east branch of the Penobscot River using our inflatable raft. We sample the nearshore environment using electrofishing equipment to identify which species are present while recording their relative abundance and biomass. Main stem sampling is carried out. We use our 18-foot aluminum hull electrofishing boat where we can actually position 2 netters at the front of the bow. And all fish captured are placed into our onboard live well, and then at the end of the transect, each species or each fish is ID'd, and length and weight measurements are taken before they are returned back into the river. Here, I just wanted to highlight the extensive efforts previous grad students have put forth into collecting this assemblage data. Prior to dam removals, the baseline assessments were conducted by Ian Corrali in 2010 to 2012. And then these methods were then immediately repeated following restoration efforts by Jonathan Watson in 2014 to 2016. And now for my master's project, I am now conducting the second phase of the post-dam removal surveys to highlight the more extended response of these fishes, 7 to 9 years following dam removal. So non-metric multidimensional scaling is one method we use to assess assemblage data, where each species is a variable in ordinational space. So there are however many species you are, that's how many dimensions you have, and this is then compressed into a 2-dimensional space for us to visualize. We use the Bray-Curtis similarity index to create a similarity matrix to identify how a sampling event compares to each other sampling event. And so sampling events that are different from each other will plot farther away than sampling events that are more similar in species composition. So first, I've plotted just the species scores to show you where these relative assemblages are occurring in species within relation to each other. And we have our anadromous species in the top left portion of the plot: Atlantic salmon, American shad, striped bass, and river herring. And in the right portion of our plot, we have our slow water generalist species. So now I'll use our pre-dam removal surveys to overlay our sampling events just to show you what these assemblages really looked like prior to dam removals. And so you'll notice we have representation of these anadromous species, largely from our tidal section of the river. But all those impounded sections, so those above the VZ Great Works and Milford Dam, all have significant contributions from these slow water generalist species. Fast forwarding to 2019 and 2020 assemblage data that I have collected thus far, you'll notice on the right-hand side of the chart is our riverine depiction. The VZ Dam and Great Works Dam have now been removed, and we'll see again where those species scores have not changed, but the sampling events, or locations of those sampling events, have changed, or at least largely shifted where habitat restoration efforts have occurred. And so you'll notice the tidal, Orono, and Milford sections of the river now all have a greater representation of these anadromous fish, as also these slow water generalist species are beginning to phase out of these areas, is that riverine habitat really doesn't favor the presence of these species. The Milford Dam is now the lowermost dam in the system, so the Argyle section is still impounded, where many of these saltwater genera species are still occurring in great abundance. And so now looking at just the resident species, we observe a significant decrease in the occurrence of these saltwater genera species throughout our study area as a result of dam removal, reducing that stagnant and slow water habitat. And assemblages are largely shifting to riverine species now. Looking a bit closer at the diadromous fishes, we see an increase in the occurrence of alewife, herring, American shad, and this is largely a result of encountering more adults during spring surveys as well as juveniles during fall surveys. And so alewife, blueback herring, and American shad are now spawning in parts of what was once their historical spawning habitat, which they had been blocked from for over 100 years. So using just fall surveys, we're able to assess the mean catch per unit effort or total fish per river kilometer of the combined shad and river herring total catch. And so using just fall surveys, again, we're trying to identify how the juvenile river herring and shad have responded. And so you'll notice during pre-dam removal surveys, the tidal section of the river was the only strata where juveniles were captured. And fast forward to the second round of post-dam removal surveys, the three highest strata in our study area um, yielded the highest catch per unit effort for these fishes, demonstrating that adults are successfully spawning higher in the watershed. Results from the large-scale habitat restoration efforts are often highlighted on a much longer time frame. So following the completion of one more sampling season in 2021, I'll have a detailed depiction for how these fishes in the Penobscot River have responded on a longer temporal scale. And with that, I'd like to thank my funding support and all those that have supported me thus far. A huge thank you to my field technicians, my lab mates, and my committee members, and all the private landowners that have generously granted us access to the river in order to sample and collect this data. And with that, I will take questions.